Financial Economics Exam Help. For any exam-related queries, call us at +1 678 648 4277. You can mail us at support@economicsexam.com or reach us at https://www.economicsexamhelp.com. 1. Zekhauser's problem. The following example casts doubt on the Bayesian view about the uncertain world. You've been kidnapped. You're rich, and you must pay ransom or face death. If you're to die, it makes no difference to you if you die rich or poor. Consider two choices. Case 1. You must play Russian roulette for your freedom, using a 6-shooter with 2 loaded chambers. How much would you pay to empty both chambers before pulling the trigger? Case 2. If there were only 2 empty chambers, how much would you pay to empty a 3rd chamber before pulling the trigger? Show that a DM who satisfies the independence axiom must pay the same amount. Suppose that you pay more in case 1 than in case 2, as I would. Then you violate the independence axiom and you cannot be represented by the VNM expected utility function. Refer to the article posted on BB. It is an interesting article. Please take time to read what he tries to say. The article sounds more like a confession from a person who used to be the believer of human rationality, as most economists do. The independence axiom leads to a very unlikely behavior that goes against common sense. economicsexamhelp.com. 3. P Beauty Contest in Tulip Mania. A. In 2 beauty contest game where players pick a number from 1 to 100, explain why the choice 100 by a player is not rationalizable. Explain also why the choice 32 by a player is not rationalizable. Try to show that 32 is a best choice against others' rationalizable strategies. You may need to go a few steps of this. Using the concept of rationalizable strategies in the 2 beauty contest game, explain why the behavior of the investors in Tulip Mania is irrational. 1. Scared by a test result. We may be misled by our perception regarding a probabilistic assessment of a situation. A probabilistic assessment has no meaning if we do not have the underlying information about the population to which the accuracy of the assessment is applied. Consider the following example. Suppose that 100 out of the total population of 1 million have a rare form of cancer. A test is 99% accurate in detecting the cancer. Now suppose that a person's test turns out to be positive that he has the cancer. What do we conclude from this? Does it mean that the person has the cancer with 99% chances? A test is 99% accurate if the following holds. If one has the cancer, then the test will be positive with probability 0.99 and will falsely be negative with probability 0.01. If one does not have the cancer, then the test will be negative with probability 0.99 and will falsely be positive with probability 0.01. economicsexamhelp.com. 1. Draw the Venn diagram. To do this question, assume the whole population is tested, and find the numbers for the followings. 1. Those who have cancer. 2. Those who are positive. 3. Those who have the disease and the test correctly shows positive. 100x, 99/100 equals 99.4. Those who do not have the disease and the test incorrectly shows positive 999,900x 1/100 equals 99.99.5. Those who do not have the disease and the test correctly shows negative. Those who have the disease and the test incorrectly shows negative. 1. Use the direct method to find the answer. 2. Also use the Bayesian updating to find the answer. 3. 2 bidders, B1 and B2, participate in a Vickery auction, the second price sealed bid auction, by submitting bids, B1 and B2, where the winner pays the price equal to the second highest bid. The values of the object for B1 and B2 are given by V1 equals 100, V2 equals 60. If the bids are tied, then B1 receives the object and pays the price as described above. economicsexamhelp.com. 6. War of attrition. Suppose that two firms, A and B, are fighting to push the other out of business. If a firm exits the market, then the other firm becomes the monopolist. The fighting costs each firm $C per unit time. If the fighting lasts T units of day, then the cost is given by CT. The longer the game lasts, or the longer both do not concede, the higher the cost will be. The profit firm A receives as a monopolist is 4 and the profit firm B receives as a monopolist is 6. Let Ta is the concession time for A and action TB is the concession time for B. The payoff for A is given by economicsexamhelp.com. The payoff for B is given by find the best response function for A. Find the NACE EQ. Minus 2 Cournot duopoly firms facing a demand P, Q1, Q2 equals 90, Q1 plus Q2, simultaneously choose their levels of output to maximize profit. Suppose both firms have the same unit cost 6. Show that successive elimination of strictly dominated strategies yields a unique prediction, Q1, Q2 equals 28, 28 in this game. Find the best response functions. Find all the Nash equilibria, including the mixed strategy Nash EQ. economicsexamhelp.com. 1. P1 strategy top can never be a best response. True or false? Show why. Your mark depends on your explanation. 2. P1 strategy top is a dominated strategy. True or false? Show why. Your mark depends on your explanation. 8. Consider the game below. 8. Median voter. 3 people, P1, P2 and P3 have to collectively pick one policy, say tax rate. Each person I has a best policy, x1 asterisk operator equals 0.2, x asterisk operator 2 equals 0.5, x3 asterisk operator equals 0.7 for P1, P2 and P3. The farther away from 11 asterisk operator the policy is, the less preferred. And the median of the announcements among a 1, a 2 and a 3 is selected. For example, if a 1 equals 0.5, a 2 equals 0.9 and a 3 equals 0.1, then 0.5 is the chosen policy. Find the best response function for P2 for the cases where no two announcements by P1 and P3 are the same, i.e., a 1 equals a 3. economicsexamhelp.com. Solution 1. Zekhauser's problem. Let us calculate the expected utility in both cases. In case 1, there are 2 chambers that are loaded. In case 2, there are 4 chambers that are loaded. If D is death and L is life, then the utility function becomes U, D equals 0 and U, L equals 1. The general form of the equation is: if we let A1 be the event that you pay the maximum sum you are willing to pay, then that means you are indifferent between A1 and 2D plus 4L. So the function becomes. For case 2 we have the function become U A2 equals U A4. This shows that you would be willing to pay the same amount in both cases when the independency axiom holds, as the utilities in both cases are the same. 1. P Beauty Contest and Tulip Mania. economicsexamhelp.com. The choice 100 is not rationalizable because the aim is to pick a number that is 2/3 of the average of the numbers picked. Suppose that everybody picks the maximum number, which is 100, then the winning number must be 2/3 of that.